All right, this is dividing decimal numbers, which is section 4.5. There's two types of decimal division problems that we're going to talk about today. The first one is going to be where the divisor is a whole number and it's divided into the dividend, which is a decimal number. Or the second option would be both the divisor and the dividend are both decimal numbers. So I gave you the parts of a division problem to kind of refresh your memory here. So we started with the original problem, which was the blue 4 and the orange 33. And we said 4 goes into 33 how many times? We came up with 8, which is that part of the quotient at the top. We then multiplied the 8 and the 4 together and got the black 32. We subtracted 33 minus 32 and got the remainder of 1. So just to refresh your memory, that's how you are working division problems. So let's look at our rules. You are going to write the decimal point in the quotient directly above the decimal point in the dividend, and then you will divide as if everything were whole numbers. So here's what we're saying. This is the problem that they gave us, and I wrote it like this. The first step is to write the decimal up in the answer, and then we're going to treat this as if it is a regular whole number type problem. So there's no decimal numbers that we're dealing with, okay? I just removed this guy here and rewrote this. So 3 goes into 2 no times. It does not go into 2 at all. But 3 goes into 21 7 times. 7 times 3 is 21. We subtract and we get a remainder of 0 and we bring our next number down. 3 goes into 9 3 times. 3 times 3 is 9. I subtract and I get a remainder of 0 and I bring my last number down. 3 goes into 3 1 time. 1 times 3 is 3. I subtract and I got a remainder of 0. So my decimal is already in my answer up there because I brought it straight up. And so my final answer is 7 31 hundredths. Okay, same thing here. We're going to bring our decimal straight up into our answer. And then we are going to use long division, just like they're whole numbers. All right, so here we go. 9 does not go into 4, but 9 does go into 47 5 times. 5 times 9 is 45. I subtract and I get 2. I bring that number down below the line and I start again. 9 goes into 22 times. 9 times 2 is 18. I subtract and I get a remainder of 2 and I bring my last number down. 9 goes into 27 3 times. 9 times 3 is 27. I subtract and I get a remainder of 0. So 52 3/10 is my answer for this one. Once again, bring our decimal straight up into the answer and then divide like we've got just whole numbers. 8 does not go into 1, but 8 does go into 15. 8 goes into 15 how many times? Well, 1 time. 1 times 8 is 8. I subtract and I get 7. So notice that I don't have anything else to keep going, but I'm going to add a 0 and see if we can get this to end up being a remainder of 0. 8 goes into 70 8 times, and 8 times 8 is 64. I'm going to subtract and get a remainder of 6 and put another 0 and bring it down. 8 goes into 60 7 times. 8 times 7 is 56. I subtract and I get 4. I'm going to add another 0 and bring it down and I get 40. 8 goes into 40 5 times. 8 times 5 is 40. I get a remainder of 0. And so my answer for this one is 0.1875. Final answer. All right, the next few that we're going to do, notice all of these have had whole numbers on the outside, and the next few examples are going to have decimals in both places. So for these, it's just one extra step. We're going to count one place here. So we're going to move this one place here and then move it straight up. So now we really do have 12 and just whole numbers to look like we're dividing by. Okay, so 12 does not go into 6. 12 does go into 63 5 times, which is 60. I subtract and I get a remainder of 3 and I bring my 6 down, and 12 goes into 36 3 times, which is 36 with a remainder of 0. So 5 3/10 is my answer. Okay, 2 more. Let's try 2 more just to make sure we understand how to move the decimals in both places. So for this one, remember everything has to be over here on that far right side when you're talking about your outside number. So I'm moving it 1, 2, and 3 places. So I have to do the same thing to the inside. 1, 2, and 3. Bring my decimal straight up from there. And so the numbers that I'm dividing by look like this. How come it's just 3? Well, any number that has a decimal right behind it is just a whole number, and so we're dividing by 3. All right, so we get started here and we say that 3 does not go into 2, but 3 does go into 27 9 times. 9 times 3 is 27. I subtract and I get a remainder of 0 and bring my number down. 3 goes into 6 2 times. 3 times 2 is 6 with a remainder of 0. Bring my 9 down. 3 goes into 9 3 times. 3 times 3 is 9. I subtract and get a remainder of 0 and bring my last 0 down. 3 goes into 0 0 times. You have to do this, guys. There's a number here. We had to bring this guy down, and we have to ask ourselves, how many times does 3 go into 0? And that's where we get this 0 number from. So my answer is 9230. You can put your decimal if you want to, but it's 9,230. All right, one last one. All right, where is my decimal number inside here? So whole number of 5, we know our decimal is here. So if I look on the number on the outside, I move it 1 time, and I'm going to move it 1 time here. What goes in this blank here if I have to move this decimal place? Well, a 0 placeholder. So now I have the number 42 divided into 50 after I've moved all of my decimal places. So 42 does not go into 5, but 42 goes into 50 1 time. I subtract and I get a remainder of 8, so I'm going to add a 0 and bring it down. 42 goes into 80. How many times? 1 time, right? Because if it was 40, it would go 2 times, but it doesn't. So I have 38. I'm going to put another 0 and bring it down. And 42 goes into 389 times. 9 times 42 is 378. I get a remainder of 2. Make a 0, bring it down, and I get 20. Doesn't go any times. So I get a remainder of 20, and we could keep going, but this isn't ever going to work out for us, okay? It's not really going to change. So for most of these that are going to have these ongoing, keep going, there's going to be a little piece in the instructions that say round to the nearest 100 or 100th, depending on what your decimal number looks like. And so for this one, it did say 100th. I know I didn't put it, but I want you to see that it does say that. So if I'm looking at 100th, I have tenths, hundredths. I would need this one extra number to help me decide if I'm going to round or not, right? This is my cutoff line, this red line. So I'm looking at this guy to see if it's 5 or more or 4 or less. Since it's 4 or less, it's going to stay the same, and so that means my answer is going to be 1.19. Final answer.